Hello everyone, this is Ankit here. Greetings from Edureka. In today's session, we are going to discuss about a very important and widely used services from AWS, that is Virtual Private Cloud or VPC. In this session, we will cover the following agenda. We will start by explaining you what a VPC is and why is it required. We will then move on and discuss about subnets and its various types. Later, we will do a hands-on wherein we will create a VPC using the AWS console. While creating the VPC, we will also discuss the critical components of VPC. Post that, we shall discuss about the important topics, that is VPN and direct connect. End of this session, we will give you the recommendation for the VPC best practices. Let's start with the basic question, what is a VPC? In order to understand, let us think about today's scenario. Today, we are facing a pandemic situation. In this situation, the utmost priority for all of us is to maintain a private sanitized space. Even when we are visiting a public space, we need to take care that the social distancing norms are being followed. Similar to this, enterprise want to use all the services available in AWS, but they want to do it in their own private sanitized space. This space is provided by a service in AWS known as VPC. VPC provides us the private space that is required inside AWS, wherein we can define our own network and also use all the services of AWS as per our requirements. So the technical definition of a VPC is, as can be seen from the illustration, let us try to understand it. A VPC is defined in a region of AWS. As we all know, there are various availability zones within the region. It should be noted here that the VPC can be spread within a region in all the availability zones. In this illustration, there is shown a region with two availability zones. The VPC is spread among both these availability zones. The other point to be taken into consideration is a VPC is generally a large network. In order to have better control over the network, the large network of a VPC is further divided into smaller groups or smaller chunks. These smaller chunks within VPC are known as subnets. So now let us discuss why a VPC is required. For an enterprise using the cloud or migrating to a cloud, the most important concern is privacy, security, and the security of their proprietary data. They are not comfortable when they need to use a public network of a cloud service like AWS in order to use their services. Therefore, a VPC provides them an extra layer of security wherein they can define their own network. It not only gives them security, but it also gives them ease of connecting to their instances or services. When we create our AWS credential, a default VPC is created. But in industry or at a production level, we need to customize our VPC. The tools required to customize our VPC is provided by AWS, wherein we can explicitly create subnets, NAT, security groups, internet gateway, etc. All these terms shall be explained with the hands-on in this session. Before we move and understand the components of what makes a VPC, let us first spend some time and understand what is an IP address. The IP address or the Internet Protocol address is a logical numerical label assigned as a unique identity to each device in a network. In more lay terms, it can be understood as every human being has a fingerprint. It is unique to each of us. Similarly, every device which is connected to a network has an IP address which is unique to itself. It's like a fingerprint for that device. Let us get more deeper into understanding of an IP address. Take for illustration the computer's IP address 155.67.35.0. It consists of 4 parts. These 4 parts are known as octets. Each octet contains 8 bits. So in all, the IP address consists of 32 bits. 4 octets, each octet consisting of 8 bits. Therefore, 4 into 8, 32 bits. Let us now understand another important topic or important definition, that is CIDR, classless inter-domain routing. CIDR is basically a methodology to represent an IP address. Let's take an illustration. 172.31.0.0/16. The /16 part here represents the number of bits present in the network ID. Let us understand it a little deeper. As explained earlier, the IP address consists of 4 octets, and each octet consists of 8 bits. The 16 here denotes the number of first 16 bits out of this 32 bits which are locked. So in short, in this IP address, the /16 denotes that in this network, this 16 bits are locked. So what does it signify? It signifies that the remaining 16 bits out of this 32 bits are available for use in the network. Therefore, the total bits which are available to be used in the network are 32 minus 16 is equal to 16. Therefore, the total number of IP addresses which can be generated from this 16 bits would be 2 raised to 16. Let us take, for better understanding, one more illustration. Suppose 172.31.0.0/28. This is a little tricky as 28 is not a multiple of 8, but let us understand. So this denotes that in this IP address, out of 32, 28 bits are locked. The number of bits which can be changed in this IP address are the last 4 bits. Therefore, the total number of IP addresses which can be generated from this CIDR are 2 raised to 4 or 16 IP address. What does this denote? It denotes that this IP address is a much larger network wherein you have provisioned it with the larger number of IP addresses which can be assigned within this network. Whereas in this IP address, the number of IP addresses available to be used within this network are very small. Therefore, classless inter-domain routing reduces the wastage of IP addresses by providing the exact required number of IP address to the users. It is also a methodology by which we can gauge the vastness or the largeness of the network it has been assigned to. Now that we have understood the basics of IP address and CIDR, let us see what are the key components of VPC. The key components of VPC that we would be talking and also discussing and doing hands-on on are the following. 1. Internet Gateway and NAT. It logically enables routing of traffic in the public network. That is, it gives us the gateway like a firewall from which our VPC can connect to the internet. DNS, standard which resolve names used over the internet into IP address. Elastic IP, it is a static IP which never changes. VPC endpoints, private connection between your VPC and other AWS services without using internet. This is one of the key features of VPC, wherein we will be discussing that in detail during this session. Network interface, a point of connection between a public and private network. Egress only IG allows only outbound communication from EC2 over IPv6. Route tables, another important feature to understand VPC. It defines how a traffic is routed between each subnet. VPC peering, connection between VPCs. We will be discussing about each of these components during the course of this session. Now that we have understood what is an IP, what is CIDR, and what are the key components of a VPC, let us understand what are subnets. As explained earlier, a VPC may consist of a large network. In order to have better architecture within this large network, we may divide it into smaller networks. So it is a concept of network within a network. It may also be understood that the large network of VPC has been divided into smaller networks. These smaller networks are known as subnets. Therefore, a subnet is a logical subdivision of a larger network. Here comes a picture of CIDR. IP addresses with common prefix are used in the same subnet. As can be seen in this illustration, 172.31.0.0/16 is the IP address of this VPC. We have two subnets here. One is known as a private subnet and the other public subnet. We have assigned a common prefix of 172.31 to both these subnets, and the IP addresses have been divided. The various types of subnets are private subnet and public subnet. Why is this a requirement? Let us understand it maybe with the example of a website like Facebook. There are certain parts of Facebook which we require access to, or which Facebook wants us to access. But there are other parts of Facebook which Facebook wouldn't want us to get access to. That is their database. This bifurcations can be done using private subnet and public subnet. When we do hands-on, we will understand how do we categorize a subnet which has been created inside a VPC as private or public. So let us now start our hands-on in order to better understand the concepts which we have understood till now. That is VPC, region, availability zone, and subnets. Let us start our hands-on and reiterate what we have learned. In this hands-on, we would be creating an architecture similar to the illustration as seen in the image. Within the AWS, we will be creating in one of the region a VPC. In that VPC, we will be creating two subnets. One is the public subnet and the other is a private subnet. We will then provide an internet gateway which will give access to the subnet to the public network or the internet. Also, we will understand how we shall create a router or a route table. We will be creating a route table for each of the subnets that we are creating and understand how important it is for VPC. So let us start this session. So let us now log in to our AWS console. We are signing in to our AWS console. So this is the dashboard which reach into when we start our AWS management console. The point to be taken into consideration here are: 1. This is the region wherein we are going to create our VPC. It should be noted there are various regions. We have chosen this region in which we are going to create our VPC. Now, how do we access VPC as a service? We can do it either by searching on the search bar, or we may go and click on the VPC service inside networking and content delivery section of AWS. We have launched into the VPC service of AWS inside North Virginia region. Now, we need to create our VPC. AWS provides us one of the wizards by which we can launch a VPC, but we shall be creating our VPC by clicking on this link. Let us first, as you may see, there is already a VPC residing here. This is the default VPC which I am talking about. This default VPC comes packaged whenever we create our AWS credential. We are now going to create our own custom VPC. Let us name the VPC as Edureka demo. Before we discussed about a topic known as CIDR, herein comes its use. We need to allocate an IP address to this VPC in the form of a CIDR block. We are just providing it 10.0.0.0/16. So basically, we are creating a VPC in which we can assign, as explained before, 2⁻16 IP addresses. Let us create this VPC with the default settings. The VPC has been created. The next thing which we discussed about was subnet. Let us understand what we did till now again. We created a VPC inside the AWS region, North Virginia. Now, we are going to create inside this VPC smaller networks or smaller chunks of this network known as subnets. We go into the subnet module. There is already one default subnet available. We are going to create our own subnet. The first subnet which we will create is the private subnet. Let us name it as private subnet. The VPC inside which this subnet will reside, we need to select it. So we are going to select the one which we created, that is Edureka demo. The availability zone. This is what I was talking about. We created a VPC inside the region North Virginia. In North Virginia, there are 6 availability zones. In the illustration which we had discussed, it had 2 availability zones. In North Virginia, there are 6 availability zones. What we are going to do is, we are going to create a private subnet in one of the availability zones. Let us select this one. The other thing to be noted here is, as soon as we associated this subnet with the VPC. The corresponding CIDR of the VPC has been mentioned here. Now we need to mention a CIDR block for the subnet which we are creating. It needs to be mentioned here. We need to give a CIDR block here, which is a part of this network. So 10.0 will remain fixed. As explained earlier, the first 16 bits of this network or IP address is blocked. So 10.0 cannot be changed. So we change the third digit or the third octet as 10/24. So we are locking in this subnet the first 24 bits 10.0.1. So it has to its dispose 2⁸ IP addresses which can be assigned within this subnet. Let us create this subnet. Herein, the first subnet, that is private subnet, has been created. Now let us create another subnet which is our public subnet. Public subnet. We assign this subnet again inside the VPC Edureka demo. We can assign this public subnet in the same availability zone which we did for private subnet, or we can have it in other availability zone. For this demo, let us create this subnet, that is our public subnet, in a different availability zone. As explained, we can now assign IPv4 CIDR block to this subnet by fixing 10.0 and assigning it a different IP address. This is the subnet which we are going to create. Perfect. Till now, whatever we have done is what we have discussed. We have created a VPC inside the region North Virginia of AWS services. In the VPC, we have created two subnets. One is the private subnet and the other is the public subnet. It can be noted here that these two subnets have been assigned to these two VPC. So within this VPC, we have these two subnets. We have also assigned the IP address, or we have defined the IP addresses for our VPC, and accordingly, we have assigned a IP address to our subnet. The next part after creating subnet is creating route table. So what is the route table? Let us understand that. Route tables are the set of rules which are used to determine where the network traffic has to be routed. It specifies the destination subnet and the gateway router to reach it. So basically, a route table is a log wherein we maintain all the rules, or we specify all the rules by which we say which subnet will communicate with internet in what way. Let us better understand it with the hands-on. Herein, there are default route tables created. One of the route table you can see has already been created for Edureka demo. This is the route table which is created by default, but it is a standard that we need to create a route table for the subnets which we have created. So let us create for the two subnets which we have created in our VPC two route tables. The first route table, we will name it as public RT. The VPC is Edureka demo. So now we are creating this route table. Similarly, let us create another route table, that is private RT, for the VPC Edureka demo. Now we have created the two route tables, but now we need to assign the subnets which we have created to the respective route tables. That can be done by clicking on the created route table and going into this tab of subnet association. So now we will associate our subnet with the respective route tables. So we click on edit subnet association. We see that there are two subnets which we have created, that is private subnet and public subnet. The name of this route table is private RT, that is private route table. Let us assign the private subnet to this route table. This basically means all the rules, all the conditions of how this subnet communicates with the router will be logged into this table, that is private RT. Similarly, let us associate the subnet with public RT route table. if we click on edit subnet association, we see again that the two subnets which we had created for our VPC Edureka demo are listed here. Now it can be noted here that it shows one of the subnet, that is private subnet, has already been associated with this route table. Therefore, we shall now associate the subnet, that is public subnet, to public RT. Done. So the other thing it needs to be noted is this is the default or the main route table which has been created as we created our VPC. These two are the route tables which we have created. One for the public subnet and the other for private subnet. Now let us understand what an internet gateway is. As can be seen in this illustration, we have our public and private. So one of the public subnet needs to communicate with the internet. How do we do that? How will we provide that gateway to public subnet so that it can communicate with the public network or the internet? For that, there is a service provided by AWS within VPC that is known as Internet Gateway. This Internet Gateway shall be assigned or shall be linked to the subnets which we want to be connected to the internet. Thus, the Internet Gateway is a VPC component that helps instances to communicate over the internet using targets provided in the route table. Let us now understand how we can create this Internet Gateway. I'm going to create a new Internet Gateway. Let us name it as Edureka Demo IG. And with the default settings, we will create this Internet Gateway. This Internet Gateway has been created, but it is right now in detached state. Therefore, we need to attach it to one of the VPCs. So here we click on attach to VPC. We select the VPC to which we want this Internet Gateway to be associated. And we create the attached Internet Gateway. Now, if you see, the status has changed from attached to detached, and it has been attached to this VPC. So let us understand or summarize what we have done till here. We created our VPC in a region North Virginia. We created two subnets within that VPC, private and public. We created for each subnet a route table. And now we have assigned or we have created an internet gateway for our VPC Edureka Demo IG. Now in the route table, we need to update the table by the rules or by the log that which subnet can connect to the internet gateway. Remember, as explained earlier, internet gateway provides us the access to internet. So here the public RT needs to be provided that access. How do we do that? We go to the tab routes, we edit routes, we add a route 0.0.0/0 and we select in this tab the internet gateway. Once we do that, we can see in the drop down the gateway which we have created. We select that and we save the route. So basically what we have done is we have created a route for our subnet to connect to the internet. For that we have provided the information in the route table. Thus till now we have created our VPC, we have created two subnets, we have created an internet gateway, and we have updated our route table by mentioning that the public subnet can connect to the internet using internet gateway, and we have assigned the respective gateway which we had created. Now let us create two instances within our subnet. Let us go here, click on EC2. We shall now create one instance each for the two subnets which we had created. We go to instances and we launch an instance. We need to select a machine or an instance. We select the default one and we configure our instance. So now we are going to create our EC2 instance within one of the subnets. Here you can see that the VPC which we have created, one is the default VPC and the other is a custom VPC. We can select our custom VPC from this drop down. Within that VPC, we have two subnets, private subnet and public subnet. This instance we are going to create for our private subnet. So we select the private subnet. Auto assign public IP. We all know that the instances which we want to create in our private subnet need not be exposed to the internet. Therefore, we will not assign any IP address to it. To do that, we will disable auto assign public IP. We will next look into storage. We will keep it as default. Add text, we will keep it as default. For configure security group, this is another important aspect of a VPC. Now, AWS provides us security group, which is at the instance level. So at the instance level, I can mention who all can connect to this instance. Suppose I mentioned that apart from SSH, I would want HTTP and HTTPS to be included in the protocol wherein we can communicate with the instance. These details at instance level can be mentioned in this section. We have just done that and we launch our instance. We will now need to create a key pair to communicate with this instance. I will use a key pair which I have already created. You may also download a new one by clicking a create new key pair, or you can click on choose an existing key pair. I shall use one of the existing key pair. Should be noted here, you can also create a new key pair. You can just name the key pair and download it. For now, we will use a already existing key pair. So the instance has now been created. Let us go and have a look at it. As can be noted here that an instance has been created and the key name is Edureka. There is no public IP address assigned to it. Let us name this instance as the private instance. Now let us launch another instance for our public subnet. Select. Next, let us follow it. Here in configure state instance, let us have a look. Herein, for the network, we use our private network, VPC network that we created, Edureka demo. In the subnet, we need to now create this instance for our public subnet. We need to assign a public IP to it so that we can communicate to this instance. So for auto assign public IP, we will click on enable. Next, we will keep it as default. The tag section will be kept as default. In configure security group, again, we may add more rules such as HTTP, HTTPS, and let us launch this instance. Again, let us use the existing key pair, that is Edureka demo. Let us look at the instances which we have created. As you may see, the status for the newly created instance is still in pending status. Let us, in the meantime, name the instance as public instance. The instance state has changed from pending to running. The other thing to be noted here is we had requested AWS to assign a public IP to it. It has done this. So now we can communicate with this instance using this public IP address. Let us go to our command terminal now and try to communicate with this instance. So now I open the terminal in which I have our key pair, that is Edureka demo. How do I connect? What is the command to connect to my instance? I can go here. I want to connect to my public instance. I can click on connect, and here in the SSH client tab, this is the command provided by which I can connect to this instance. I shall pass this command in my command terminal. And here I have now entered into my instance. That is my public instance. Let me now use the internet from this instance. Let me ping google.com. As you can see, it has started communicating with Google and is exchanging packets. Similarly, let us now connect to the other instance which we have created, which is the private instance. It needs to be noted here that the private instance has no IP address. So we cannot connect to this, but let us try doing that. We use again the SSH client provided exit out of our public instance and we paste for our private instance. As you may note now, it is trying to make a connection with the instance, but it is being refused, so it is not able to connect. Yes, so you can see this error now. Connect to host 10.0.1.85 port 22 connection timed out. It was not able to connect to that instance. It is obvious because there was no IP address assigned to that instance. Now that we have seen that we are not able to connect to our private instance, we can try connecting to our private instance through our public instance. So what we'll do now is we'll access our public instance. In that public instance, we will give a certificate which is required to access private instance. So we will use the network within our private cloud, wherein we will try to connect our public instance with our private instance. So let us do that now. I connect to my public instance. So now we have connected to our public instance. So now let us connect to our private instance from our public instance. So we take the sudo access of our private instance by writing this command. Let us create a blank PEM file which will contain the key to connect to our private instance. So we have created a new file, that is my.pem file, in which we will now insert the key required to connect to our private instance. I will copy paste this. I go to my command terminal. I connect to my public instance. Yes, so I have connected to my public instance. Let us now take a sudo access to this machine or to this instance. We now create a Vim file access.pem to connect to our, in which we will pass the security key required to connect to our private instance. I will copy paste the key which is there in Edureka demo to my access.pem file which I am creating. I will save this. I will now give it the read write access. And now I will attempt to connect to my private instance. Let me modify the key name before passing it on the command line. Yes. Okay, I misspelled the name of access. It should be ACC. Let us do that. Yeah. As you may now see that I have changed the IP address. I am now logged into my private instance from my public instance within the VPC. Let us now ping Google from my private instance. So I am telling my private instance to connect to Google. As you may see now that it is not able to exchange any packets. It means that my private instance doesn't have any connection with the internet, which is what we want our private instance to be. Many of our private instances inside our private subnet needs access to the internet. It may be because of practical reasons like updating our database or updating our security patch, etc. So how do we do that? For that, VPC provides us a concept of NAT gateways. NAT gateway is created so that our private subnets or the instances within our private subnet can get access to the internet. It needs to be noted here that private NAT gateways are one-way access. The full form of NAT is Network Address Translation. NAT devices enables instances in the private subnet to access the internet or other AWS resources. But it prevents the internet from initiating connections into the instances. So it's a one-way communication wherein our private subnet can connect to the internet using this device or using this NAT concept. How do we do that? We need to create a NAT. We create a NAT gateway. It needs to be noted here, or it can be seen from this illustration, that the NAT gateway is created in the public subnet. We need to create Edureka demo NAT gateway in the public subnet. The public subnet of Edureka demo. We select that. We allocate to it a IP address by using the concept of allocate elastic IP address, and we create this NAT. Let us go and look whether in what state it is. As you can see, we have created a NAT gateway. It has been assigned inside VPC Edureka demo under the public subnet, and it has been assigned a private IP address. Now we need to go to the route table and update our route table for the private subnet or private RT. What we need to do is we need to give it a route 0.0.0/0 and connect it to the NAT gateway. You may see here that in the drop down the NAT gateway which we have created. Therefore, what we have done now is we have created a NAT gateway inside our public subnet. We are now connecting or providing a route for our private subnet to connect to this NAT gateway. This NAT gateway now will be connected to our IG or internet gateway and can access the internet. Let us do it. We have created our routes and updated our route table. Let us see whether our private subnet can get access to internet as it has been routed via the NAT. I am in my private instance right now. I tried pinging google.com before NAT gateway. It did not receive any information back from Google because it couldn't connect to or it couldn't ping that website. Now let us do it again. Before that, let us check whether NAT gateway has become live. It is still in pending mode. Let us wait before its status changes. Yes, so now the NAT gateway is available. Let us try pinging google.com. Perfect. As you can see now, the private subnet is able to access google.com. Why? Because we have created a NAT gateway. This NAT gateway is connected to the internet gateway. For now, the private subnet or the instances within the private subnet can access the internet via NAT gateway. This gives us the practical gateway wherein we can update our private instances. Also, it is very important to let you all know that once we have done or completed our demo, it is prudent to delete all the instances, otherwise you may be charged for the same. Let us do that so that we can repeat whatever we have done. The first thing which we need to do is delete our instances. So we have created 2 instances. Let us delete them. I am doing this so that we can repeat whatever we have done. We had created 2 instances, one instance in our private subnet, that is private instance, and the other instance, that is public instance, in our public subnet. Let us delete one by one. We go to instance state and we terminate the instance. Let us do it similarly for our public instance. Instance state and terminate our instance. So what we have done now is we have terminated our instances within the public and private subnet. Now the whole thing is we need to delete our whole VPC. So the first thing which we need to do is we need to delete our NAT gateway. Let us delete the NAT gateway which we created. We go to actions and we click on delete gateway and we type in delete. It has been deleting. It will get into delete stage. Once we delete our NAT gateway, which was used to access internet by the private subnet, let us go and delete our internet gateway. Before we delete our internet gateway, we need to delete it from our route tables. Otherwise, it may not allow us to delete it. We go here, we go to our routes, we edit our routes, and we delete our internet gateway. Edit routes, and this has already been deleted, the NAT gateway. So it is giving us the error. We delete that part also. Once the internet gateways have been detached, let us now delete the first, detach it from our VPC. It has detached from our VPC. Now we can go to our VPC. We need not delete our subnets one by one. What we can do is we can now delete our whole VPC. So we delete our VPC. We need to type in delete and delete. Herein the VPC is being deleted. With this, we have deleted all our instances within our subnets and we have deleted the VPC which we have created. As we did in our hands-on, we had given to each of the instances a security group. We had mentioned SSH, HTTP, and HTTPS. Therefore, security groups are working at an instance level. Security group is required to control the inbound and outbound traffic of your EC2 instance. It acts as a firewall at the instance level and not at the subnet level. So basically we are assigning the security groups, or we are assigning in layman terms who all can access our EC2 instances. AWS also provides us with an extra layer of security by the name Network ACL. Network Access Control List. It is one of the features in AWS. As you can see here, this is the default ACL list or NACL list which has been created. We can assign Network ACL to each of the subnet which we created. It is an additional security layer, controls the inbound and outbound traffic rules at a subnet level. So it means that at a subnet level, we can have one more layer of security, which will then overpower the rules which we had for our instances or the security groups which we have assigned for our instances. It allows us both allow and deny rules. Therefore, the basic difference between network ACL and security groups is network ACL are stateless. It responds to the allowed outbound traffic and are subjected to the rules of inbound traffic. Security groups, on the other hand, are stateful. They respond to the allowed outbound traffic and can flow regardless of inbound rules. Importantly, NACL are defined per subnet. It is an extra layer of security. Security group have to be defined at an instance level, and every instance can have a different set of security groups. Lastly, a subnet can be assigned only one NACL, and if not associated explicitly, it can be associated implicitly with the default NACL. Whereas in security group, an instance can be assigned 5 security groups, and each security group has 50 rules. Now let us understand about another important concept, that is VPC peering. This is one of the ways by which we can connect different VPCs. As you may all understand, in enterprise, there will not be only a single VPC. Different groups within the same enterprise For example, the data analytics group and say the data science group may have different VPCs. They may want to communicate between each other. AWS provides us a service known as VPC peering, by which we can connect one-to-one all the VPCs within the AWS. It may be in the same region or it may be in different regions. We can define the rules by which VPC peering can connect within different VPCs. This has an advantage wherein we don't need to connect two VPCs through a public network. It can be done using VPC peering. VPC peering allows us to connect one VPC to another VPC via direct network route using private IP address. You could peer with VPCs with other AWS account. It can be paired with other AWS account as well as with other VPCs in the same account. It has to be noted here, there is another service which is known as transit gateway, which can also be used in order to connect various VPCs. But that is a different topic of discussion. So now in this diagram, we illustrate how a VPC peering typically occurs. Here you may see that there are two VPC with two different IP addresses assigned. We need to have a connection between them. VPC peering is the service which we are opting for. We update the security groups to ensure that the traffic to and fro from the VPC peer is not restricted. As can be seen in this illustration, the peering request has been accepted by the blue group. Now there is a two-way connection between these two groups or these two VPC. To activate the VPC peering connection, the acceptor must accept the peering request as has been accepted by the blue group here. The request expires after 7 days if there is no action taken on the request. Once this peering request has been accepted, then we can create routes to connect the various instances between these two groups. Now we can update our route table once the peering request has been accepted. Update the route table of both the VPCs to enable the flow of traffic between them. Now that we have understood how a VPC is created, what is VPC peering, the other most important service of VPC is VPN and direct connect. At enterprise level, as can be seen in the illustration, the enterprise may have a data center which needs to communicate to a VPC. The existing data center may be keeping a copy of their data in their VPC or may have additional space in the VPC. In short, the existing data centers of the enterprise needs to connect with the virtual private cloud of that enterprise. So how do we do that? We can do it in two ways. One is virtual private network, wherein the concept of virtual gateway exists. This virtual gateway and the customer gateway can connect with each other. The two tunnels, the blue lines here, shows the two tunnels or the internet connection by which the existing data center has been connected to our VPC. VPN is a service that helps to connect your VPC to your data center through IPsec, Internet Protocol Security Protocol. So as we may all know in layman, the transfer here takes place with Internet Protocol security, or rather it takes place in an encrypted form. The security here is much more higher than connecting with the VPC via a public network. It is a secure connection between your on-premise equipment and your VPCs. It needs to be noted here, the blue lines here denote internet. Now, what if this internet connection is patchy or the speed is not up to the mark? Also, there is still some level of breach of security which may take place on these connections. To avoid this, AWS is providing with a service within VPC known as Direct Connect. So what is Direct Connect Gateway? Direct Connect is a network service that provides a dedicated network connection from your premises to AWS without using the internet. So how does it happen? It happens in such way that there are vendors who provide for each region Direct Connect hub. Now the customer's data center can connect to this Direct Connect gateway. There are third-party vendors who can lay down these lines. In short, the direct connect gateway are connected to the endpoints of the region with high quality fiber. Their speed can go up to 100 Gbps. And these are connected directly to the customers, the data centers. It provides us the advantage wherein we have higher speed of connectivity between the customer data center and the VPC on the cloud. It provides us with a dedicated line which gives us higher speed of connectivity between the customer data center and the VPC. So what are the features, direct connect features? Private connectivity to Amazon VPC. The speed is having high elasticity from 1 Gbps to 10 Gbps connections. Connections and virtual interfaces are managed easily. Enhanced security through 802.IQ VLANs. It reduces the bandwidth cost and consistent network performance. All of the major larger enterprises go with this feature of VPC. It is compatible with all AWS services. Let us summarize the difference between VPN and direct connect. VPN, it can be connected via the internet in a secure way. In direct connect, we connect it via dedicated lines without the internet. VPN is suitable for small workloads. Direct connect are suitable for large and medium workloads. In VPN, we have the bandwidth constraints. In direct connect, we have virtually no bandwidth constraints. In VPN, only resources inside VPC can be used, while in direct connect, all resources of AWS such as S3, DynamoDB and VPC can be used. In VPN, the connectivity and speed is not stable, while in direct connect, the connectivity and speed is stable. Let us end this session by recommending you 4 best VPC practices. Certain best practices are: we need to design or architect our VPC thinking about mid to long-term horizon. We need to maintain proper logs of what is the outflow and the inflow of connections with our VPC. We can monitor our VPC using services like Amazon CloudWatch. We need to have proper use of all the availability zones of our VPC. This acts as a backup in case one of the availability zones are not available due to certain issues. Also, importantly, we need to study more in details about the security aspects such as security groups and NACL. The network addresses which we assign to our VPC should also be looked into in details so that it supports the growth of our VPC from mid to long-term horizon. With this, we recommend you to go through these official documentation from AWS on VPC. So before ending today's session, let us summarize what we learned today. We had a session wherein we learned about the basics of VPC, what and why. We understood what is a subnet. We also did a hands-on wherein we created a VPC in one of the region and we created 2 subnets, that is a private subnet and a public subnet. We understood how route tables are updated. We created an internet gateway and assigned it to our public subnet. Later, we also learned about NAT gateway, which is critical in order to connect our private subnets with the internet gateway and eventually with the internet. We also learned about VPC peering. Post that, we discussed about VPN and direct connection. I hope this instigates all of you to learn more about one of the most important topics of AWS, that is virtual private cloud. I wish you all the best. Thank you.